All right, so you might say, oh my gosh, I did this back in 4th grade, and you're probably right. I don't remember exactly when it was, but it probably was about 4th grade. To find the quotient, obviously they probably wouldn't use those words, maybe they did, I don't know. But to find the quotient means divide. Okay, so we're trying to find the quotient of 56 and 8. So if you remember, we have to do it long division. So I'm just going to kind of refresh long division. That's why I'm starting with this simple problem. I always taught that kind of pretend when you divide that this breaks or falls down here, and then this falls in to that trap, I guess you could say. I don't know how you want to call it. So that's how it's set up. 56 divided by 8 is set up like this. So to think back, basically, you say, okay, what can I multiply 8 by to go into 5 and nothing? So what can you multiply 8 by to go into 56? So you might try a few things. 8 times 5, well, that's 40. So let's keep going. 8 times 6, that's 48. 8 times 7, hey, that is 56. So we put a 7 up top above the 6. 8 times 7 is 56. And if you remember, we subtract these two numbers, giving us 0, and then this is your remainder. So basically then, example 2 here, so let's do one where you have a remainder of a number. This says find the quotient of 42 divided by 5. So again, this breaks, the 42 falls in the trap, so it's set up like this. How many times can 5 go into 4? It can't. So how many times can 5 go into 42? Well, I already said 5 times 8 is 40, so I know 8 works, but 5 times 6, but 5 times 9 is 45, which is too much. So we have to do 8. 5 times 8 is 40, so we put that number here. And then again, we subtract. 42 minus 40 is 2. So in this case, we have a remainder of 2. Now I'm sure as years progressed, you went on and you put a dot there, a period, and brought that up, and then put a 0, brought the zeros down. Okay, how many times does 5 go into 20? Well, that's 4. So the answer for this is actually 8.4. But in this, we're not necessarily using long division to divide integers. We're going to use long division to divide polynomials. So when we get to this step, we just stop and say, okay, that's our remainder. And there's actually a special way to write the remainder, but I'll explain that in class when we actually start doing problems. So looking here at example 3, let's find the quotient. Again, what happens? This breaks, and then 2x squared gets stuck in the trap, so we have 2x squared divided by x. Now, you might say, okay, x doesn't go into 2. You're right, it doesn't. We need to look at this as one whole term and say, what do I need to multiply x by? And I'm going to write that differently. What multiply x by to get 2x squared? Okay, and what do you have to multiply x by to get 2x squared? Well, I know I have to do it by 2. Okay, so we'll have 2, and then the other part is x. 2x gives us 2x squared. If that's too confusing, which it's kind of tough, especially if you're already struggling with multiplying with exponents, another thing you could do, instead of this first step, you could say, okay, 2x squared divided by x is what? Now we talked about last lesson that when you divide variables, you just subtract your exponents. So really, 2x squared divided by x is going to change into 2x to the first power. Because 2 minus 1, it gets rid of one of our x's. Or written out, you have 2xx, because that's 2x squared over x. One of your x's cancels, leaving you with a 2x. So either way you want to look at it, it works. So then, just like we did before, we take 2x times x, well that's 2x squared, and we subtract that. So 2x squared minus 2x squared is 0. So x goes into 2x squared because there is no remainder. Or we could say x is a factor of 2x squared because there's no remainder. Just like up here, we should know that 8 is a factor of 56, and so is 7. They're both factors of 56 because they don't create a remainder. Now here, we can say that 5 is not a factor of 42 because it creates a remainder of 2. So there's no problems for you to try for these 3 examples because this was just kind of the basis of long division. So let's actually start dividing some polynomials here.